Boy, that's a cute little hydraulic cylinder rod. Uh-oh. That wasn't supposed to happen. Well, guess we're going to have to make a new one. Hello, welcome to Topper Machine. I'm Josh Topper. So this rod came in yesterday, broken already. I did not do that. And I can tell right now this is a friction weld, this knuckle on here. So we're going to have fun trying to cut that off. It's going to be a very, very hard cut, but we're going to do it anyway and get this back to the customer as quickly as possible. The first thing we need to do is figure out exactly how long this rod really needs to be. And whether you can see that or not, there is a bit of a gap from the break, so it's going to be kind of a guessing game to get it as close as possible, but we'll go ahead and measure that, and then we'll measure up the threads and figure out what we need. Okay, first thing we need to do is figure out how long we need this rod. And being that it's already cracked and a little gap there, it's going to be fun to figure out. But we take our handy dandy rule here. This is a 24-inch rule. Hold it up to the lip on the shoulder. And it looks like we need 10 7/8 inches to the shoulder here. And overall length, you know, we're just trying to get it close. Looks like it's 13 1/16. So now we need to figure out what the thread is. And we're 870, so that's 7/8, just under. And they generally, what I've seen with these hydraulic cylinders, these rods, is they go undersize a few thou. Mostly it's when they have to do a piston that's close fit. So it's 7/8 and 14 pitch. All right, so what we're going to do is we're actually going to chuck this up on the shaft, and we're going to cut this head off. But we're going to cut it off in a fashion that'll give us a stub shaft, so that when we turn the new cylinder rod, we'll actually drill in and make a stub for this end to fit into to keep it true and everything, and then we'll weld it back up. So let's get this up in the lathe, and we'll get it cut off and ready to go. The other thing is soft jaws. Make yourself some little plates. These are 16 gauge aluminum. Aluminum works great. Brass works good. Bronze. Any soft material, because you cannot chuck up and hold on these chromed rods. They're very slippery. Your hard jaws, they'll just slip, and then it'll actually, with the new stuff, will tear the chrome, and then you got a junk rod. So you need a little soft jaw of sorts, which is, you know, like I said, aluminum works awesome. Bronze, brass, anything soft. So let's get this chucked up and let's get it cut off. Okay, so I need to adjust my cutoff tool. I try not to run a whole lot of stick out because I don't like that, and it doesn't give me the rigidity when you got a lot of stick out, so you try to keep it short. I was a little shorter than I thought I was going to be. So I just heard it touching the tool post, just a little tick. And I stopped there and backed it off. And so because this sits at an angle, we'll run it out a little more and then adjust it down so it stays at or below our center mark, and then finish this cutoff. All right, so we got our end cut off, and I created a little stub shaft here, 1/2 inch diameter. So what we'll do is we'll take our new rod, we'll drill a 1/2 inch hole in it so it slides together, and then that gives us to keep it straight on the shaft and a place to weld. Like I said, these are friction welded from the factory, and sometimes that friction weld can be extremely hard. I've seen them where I couldn't even scratch them with carbide, or barely even a grinder, but this one wasn't too bad. So let's get the shaft up in the lathe next, and let's get making the end for this to go in, and then we'll flip it around and do the other end. Okay, so there it is all together. We drilled and reamed it to match the 1/2 inch stub that I put on there, so it's a nice tight fit, and that'll keep everything straight when we go to weld it together. Now, we turned a step here, and we turned a step here. I measured off of this surface, this flat here on the eye, so we need to get that distance to get our length down here. So what I'll do is I'll add this step and this 1/16 here. So this was a 1/4 inch, this is a 1/16. We add those together, and then we subtract that from the overall length we need to the end of the shaft here where the threads end, and then we have that distance measured out, and that's where we turn our step to. So let's get it back in the lathe and let's get this end started on. So what a lot of guys don't realize is how slippery this chrome bar really is. This stuff is very slippery, and that's again, why this sacrificial soft material is in here. This is aluminum. It grips the shaft, but if it does slip, it doesn't scratch the shaft, doesn't scratch the chrome off. Now, the first pass on this chrome is very hard, and it's hard on inserts, so you got to take a light pass, get through that chrome, and then you can go to town. So let's start cutting. I've already got this cut the length. Now we're going to cut that step for the threads and the piston. This is the only good thing about winter, is I can grab a chunk of snow and cool the part off that I just ran. Okay, so the next thing we're going to do is there's a relief groove right here. We're going to cut that. We're going to cut this chamfer, and we're going to cut this relief here that goes in as deep as the thread pitch. Now, this chamfer here, the way I understand it, is when the piston is all the way at its max travel up against the gland nut, this little chamfer here is where the oil starts coming back in to give it that little bit of a push to get it started, and then that causes it to go. So we got to put that in, otherwise this cylinder might not work. Alright, now that all of our features are cut in that we need, we're going to set up the lathe for threading. That engages our lead screw from our feed rod to our lead screw. I've already slowed down the RPM to where I want. Now we need a 14 pitch thread, which is an AE here. So we move the change gear to that position, and then E and A. Now we should be set up for our 14 pitch thread, and we can start threading our shaft. Next thing is make sure your compound's at the 29.5 degrees, which this one pretty much lives there. Back your compound out, turn it into a 0, and I've already changed out my insert to a threading insert. I always use my threading insert to start. I put a little chamfer on my, start chamfer on the end of my shaft. Bring it in, touch it off, and you can zero either your digital readout or your cross feed screw. I usually just use the cross feed. And I turn it in and engage the feed nut. Back, 0, take more on the compound. So here's our new rod. It's threaded. Got the recesses on it that it needed, the chamfer here. And now this is what I've got to weld to, this groove up here. Now what I'm going to do is I'm going to get some thin sheet metal, wrap it around there with a hose clamp to protect the shaft, and then weld this all up, and it'll be ready to go to the customer. So let's get that finished. All right, so we're back here in the weld shop, and I didn't have any shim stock and stuff that was thin enough to actually get it to wrap around, so I just wrapped it in some masking tape and then slid the cardboard tube back over it to protect it. The thing with welding these cylinder rods is you got to be careful not to get them too hot, but you got to get them hot enough to weld. This particular customer, when they started having me do this stuff, I'd never done cylinders before, or cylinder rods. I've welded up barrels and done things like that, but they showed me one they had sent out to another shop, and they got it so hot that the chrome had burned off about 3 inches from the weld. So that's just too hot. So what we're going to do is we're going to tack it up, and just be careful. I got a light amperage. My ground is clamped through the eye here instead of the rod. We can't be on the rod, trying to keep the heat out of it as much as possible. So let's tack this up and see how it looks. There it is, all done, brand new. Customers should be happy with this. They can put it back together and get back to work. Come a long ways from this. So, until next time, get out in your shop and get it done right the first time.